I'm Phil, and today I'm going to explore the UNIHIKER M10 from DFRobot. So let's have a look at what it is. The It's a Linux computer in a format of microbit. So it's got the microbit edge connector, and it's got quite a few peripherals on board. It's got a nice touchscreen, and I purchased this about a week ago, and it arrived quite quickly from DFRobot, and they packaged both the UNIHIKER M10 and the K10 all for the normal price of $79.90. And that's the regular price just for the M10 on its own. So you can use this for all sorts of applications, Internet of Things, home automation. I'm interested in using it for robotics and STEM education. And I'll also use it as a component in a weather station. So let's have a look at the hardware. If we look at the front and the back, you can see it's just loaded with peripherals. So it's a bit like a Raspberry Pi, but in a nicer format, particularly with the edge connector being compatible with microbit. So it's got a microphone and buttons on board. That's in addition to the touchscreen, USB, and a micro SD card reader. And it also has an accelerometer and gyroscope, buzzers, and access to ports. And the 4-wire I2C port gives you access to gravity devices, and the other GPIO ports you can also use with other gravity devices. So let's just have a look at the specs of it. It comes with 512 megabytes of RAM and 16 gigabytes of flash memory, and the operating system, the Debian, sits inside of that. Communication-wise, we've got Bluetooth and Wi-Fi, but in addition to that, there's the USB port. A nice screen with plenty of color and good resolution, and it's also touch sensitive. So they're the sensors we've mentioned, and the actuators. You've got the buzzer and the LED on board. So quite a nice package on its own. But what's quite nice about it also is that when you look at the edge connector and the ports, these are the ports that you've got access to. So ports like the onboard LED and the buzzer are also accessible by your program. So you've got button A and B, just like microbit, but there's also a home button, which is not shown on this diagram. And you've got access to other ports that you can manipulate. But the real fascinating thing about it, it's microbit compatible. So if you look at microbit, there's microbit here and the edge connector. And if you look at the mapping of all the pins and the ports and compare it with the UNIHIKER, they're compatible there, which means you can plug in boards for microbit straight onto the UNIHIKER. Quite a nice feature. If we move over to what you can plug in, best to stick to gravity components, but I'm also using it with Seeed Studio Grove components. So I've already got the ones in yellow here are the ones that I've got, and I can use not only the hardware, but DFRobot supports the APIs directly into its IDE called Mine Plus. So you can see there's quite a few uh, gravity devices you can use with uh, the computer. And I've ordered a few more extra ones so that I'll be exploring motor control with the robot. And they should arrive next week. Software-wise, you've got Linux, and it means you can go straight in on a remote terminal and just treat it just like a Linux computer. So you've got the Debian operating system, and you can play around with the command line interface, and you could do a PuTTY SSH on that to access it. But what's nice is that it supports directly Jupyter notebooks, and it's got a fantastic IDE called Mind Plus, and you can run that either online or on your own computer. So it runs on Windows PC, and there's a nice documentation for it, and there's plenty of online help. It has a communications program called the Linux Plus Link, and you need that. So this program called Mind Plus is more than just a text and graphics editor. It allows you to connect to a remote UNIHIKER computer. So I've been doing a bit of experimenting, and I've been able to install Node-RED. So it worked quite nicely. The only thing is I can't access the port, so I would have to do a bit more work in the configuration of the GPIO ports for that to work. Communication-wise, you've got Wi-Fi on board, and it can either set up its own hotspot, and you can it emulates a remote terminal over USB. So file transfer, I've been using the WinSCP, and you've got full access to file control. And again, with communications, it has a onboard MQTT server, and that works quite nicely. So let's look at some of the projects that I've been working on. So my projects, I've extended the reference project that comes in. You get quite good documentation. So in the documentation for the smart home temperature and humidity monitor, I've modified that, and I've used the BME 280 as an example. And I've done it with both Python and with blocky code. So just looking at that project, here's my desktop. And this is the arrangement of my hardware. So I've got the UNIHIKER on the top there. You can see how I painted the screen with the parameters measured from the BME 280, temperature, humidity, and pressure. And I've also played around with the graphics, and I've been looking at monitoring the status of the push button. When I press the button, the 0 will change to a 1. And so you can see what it looks like on the screen. And I'll just have a look at some of the components for that. So the objective here is to, let's have a look, to use UNIHIKER and learn about its ports and the use of gravity devices. And I'm collecting data, in this case, from a BME 280 for temperature, pressure, and humidity, and also the status of the push button. I want to show that remotely on the LCD, but also I'm going to publish it using the onboard MQTT server that comes along with the operating system. And I'll be looking at file transfers, and I want to look at some extras, clock. So it's also a little bit about graphics programming. Hardware-wise, the components, Well, UNIHIKER, gravity, the BME 280, and the gravity push button. And here's my configuration and how it's connected to all the ports. Software-wise, I'm using Mine Plus, and the code for that, here it is here. And we might go across now and have a look at the construction of that. I'm using ping pong libraries for the gravity devices, and also for the MQTT. So project-wise, I've saved that, and I'm able to execute it and get the results on the LCD screen. Let's go across and have a look at the software for that now. I've installed the Mine Plus software on my computer, and it looks like this on the screen. So just having a look at it, navigating through the program. On the left, we've got all the various controls, and these expand in the middle here. Then the work area is in the middle, and on the right, if we just pull that across, we get the equivalent code in Python, and we also have a remote terminal that connects to the UNIHIKER M10 computer. So the way that you work with this is that you go to extensions, and it works a lot like Scratch. So it's based on the Scratch program. So we wanted to add an extension for UNIHIKER M10. We just select that, and we've added it. And for many of my programs, I'm also using the MQTT library, so you can select that one too. There are other ones, but the best ones for devices is the ping pong library. And as an example, if you wanted to use the BME, so we can look right on the bottom, see if we can find a BME sensor. Let's have a look. There's ultrasonic. There's one sensor. So there's a BME 280 just here. And if you just press on that, we've now added the BME 280. Seems to have disappeared. Okay, just for demonstration, we might just pick another one. We might pick the BME 680. And now we've got both the BME 680 and the BME 280. So we don't want both. We might get rid of one. And when we go back, the libraries and the APIs are accessible on the left column. So here we've got the MQTT library for initializing, publishing, and also for subscribing to a topic on MQTT. The UNIHIKER library, lots of commands for drawing on the screen, both text and objects like circles. And if you wanted to use any of those, you just simply have to bring it across and put it under your start. So here we go. We've got a very simple program that at X and Y on the screen with a font of 20 and a color blue, it's going to show UNIHIKER on the screen. After creating some variables, you might like to create one called push button, make a variable. Let's call it button state. And we'll bring that across. And in the forever part of the program, we might actually initialize the screen. And put the button state here, and we'll set that to what we find on the UNIHIKER's commands. So if we go down further, we've got pin operations, and if we wanted pin 24 to be an external push button, we want to read that, and it'll become a digital. There we go. And we just select pin 24. And that so our variable button state will now be set to the status of our external push button. And this is how we create programs. So once we're happy with that, we can then remotely connect to our UNIHIKER, and we're successfully connected now. And I'm going to load a program that I've previously constructed. So we'll load a project, which is the Bitmaker one. And here's a program I've already designed that shows a number of text statements on the screen. And we're going to read from the digital pin. And while it's P1, that allows us to use the Grow Bitmaker board, which is using pins 0, 2, and 1. So the output pins for the LEDs here are 0 and 2, and the push button is on, the actual button is on P1. And all we're doing is just flashing the LEDs on this project. And if we wanted to see what the Python equivalent is over here, and we could continue separately with that if we wanted to. And when we're ready, we just run the program and it will automatically download that to our UNIHIKER. And that's an example of constructing software on the DFRobot UNIHIKER M10. This is the UNIHIKER M10 from DFRobot. And in this configuration, I've got on port 24 a gravity push button, and I've also got on the I2C port, which comes in on this side, I've got a BME 280, which is measuring temperature, humidity, and pressure. And I'm displaying all of those results, including the status of the push button, on the screen of the UNIHIKER. And to change the state of the push button, I just show that, and you can see that it's showing a different result when I press the push button. And that's the UNIHIKER from DFRobot. So I was quite happy with the results of that project. I was able to learn all about using the UNIHIKER and see how the ports and the gravity sensors worked. I collected the data. Well, it was, in this case here, it was from the BME 280. So I'll have to edit that and change it. I was showed the results on the LCD and published it on the MQTT server. I was able to use file transfer, and I was able to get the program to work quite nicely. So another project that I tried was getting the Bitmaker. Now, Bitmaker comes from Seeed Studio. So let's have a look at my desktop for this. So we've got the UNIHIKER M10 sitting on a Bitmaker board. So Bitmaker allows microbit computers to work with Grove modules. So there are Grove sockets that plug into Grove devices and I wanted to see if this would all work and were there any compatibility issues. So here's my objectives here. I wanted to test the UNIHIKER M10 with Bitmaker and test the Grove LEDs and the LED push button. So my hardware devices, first of all, we've got the computer, the UNIHIKER, and from Grove and from Seeed Studio, we've got Bitmaker. And looking at the board, the Bitmaker looks like this. You can plug in on the bottom there, you can plug in 6 Grove connectors. And the microbit would normally plug into that edge connector socket. But in this case, I'm going to plug in the UNIHIKER. And the Grove components, I'm using Grove LEDs and a red LED button. And the connections, this is how it's all connected together. And it's quite nice because the ports are numbered in the same way, and you just have to keep that consistent with the software. Software-wise, I'm again using Mind Plus, and this is what the program looks like. So not hard. All it's doing is flashing the LEDs and checking the state of the push button. And it just goes around and repeats that. So you'll see that on the video with the desktop demonstration quite shortly. So overall, I was able to get the Bitmaker to be compatible with the UNIHIKER M10. And I tested quite satisfactory with the Grove components, and it all worked quite nicely. So stay tuned, and I'll give you a desktop demonstration of that. This is the UNIHIKER from DFRobot, and I've got it sitting on top of a Seeed Studio Bitmaker, and I want to test to see whether the UNIHIKER is completely compatible with the microbit edge connector. So this is the aim of this test. And what I've got on Bitmaker, I've got LEDs. The first one over here is a LED button, and the other LED is also connected to Bitmaker. So the LED button is connected to port 01, and the standalone LED is connected to port 2. And all of this is mounted on Lego baseboard. And I've got the results on the UNIHIKER screen, and when I press the button, I'm pressing the button now, it will change the state to 0. So I'll remove it and it'll go back to 1. And the programming of all that is done by the Mind Plus program, which is an IDE that converts blocky code into Python. But the IDE is more than just a text editor and a graphics editor. It also has a remote terminal access to the UNIHIKER via the USB port, and it then downloads the program to the UNIHIKER. And the result of this is that the UNIHIKER M10 is compatible with boards for the microbit computer. So my final project for today was installing Node-RED and treating the computer, the UNIHIKER, as a Linux box. I just used the standard commands. So I also wanted to test extra Node-RED nodes, particularly for the BME 280. And my hardware, I'm using the Gravity BME 280 from DFRobot. And it's a different addressing scheme, or a different address compared to the BME 280 that you get from Seeed Studio. Otherwise, it's identical. Code-wise, I was able to get Node-RED to do very simple things like this, like a Hello World program worked without a problem. And I was able to access the Node-RED because Node-RED on the UNIHIKER was acting as a Wi-Fi and a network web server. And so all of these graphs came to my PC, Windows PC, but I wasn't able to get the BME 280 to work. So there is a problem in the mapping under Node-RED and the Node-RED software. I think it would be possible to do some work and edit the configuration files for Node-RED and to do a bit more probing into how pins are accessed on the UNIHIKER. So execution-wise, I was getting these sort of errors. And while it did install and it was able to do simple programs, and it shouldn't have a problem at all in doing the communications projects, and even using the MQTT, that shouldn't be a problem. Besides these projects that I did, there are quite a few projects that were done by others, and these include robot projects, Internet of Things, and integrating an AI assistant with UNIHIKER with ChatGPT. And the final one is reporting on the Geiger counter measurements to monitor background radiation. Okay, so these are the projects for the UNIHIKER, and the references, well, go across to DFRobot, both the shop, and we'll just open that up now so you can see what it looks like. So there's the UNIHIKER, and if you go down a bit further, you'll be able to get the K10 and the M10 bundled together for the normal price of the UNIHIKER.